For the second one of these videos, we're going to go through and just do two examples, and then I've got a third video where we do two more. Hopefully the first one didn't drive you too batty. The hardest part of this is trying to figure out, where do I go? How do I start? So let's take a look at this first one here. Again, I like to start with the side that gives me a lot of things to deal with. So notice how busy this is right here. Maybe there's something I can do with this. So let's go ahead and work on that left-hand side first. So, why is this not? There it goes. Um, so we're going to start with that left-hand side. We'll write it here. So 1 minus sine squared theta divided by 1 minus cosine theta. All right, well, so how do I start with this? Well, somehow at the end I'm going to end up with negative cosine theta. So something's got to happen with all this. A lot of stuff's got to happen. A lot of stuff's got to go away. So what we want to do first is I need to get this denominator to also be the denominator over here. So that means I got to introduce numerator and denominator of 1 minus cosine theta. So we start and we take the 1 and turn into 1 minus cosine theta divided by 1 minus cosine theta, and then subtract from that the other fraction. And this is why in the beginning of the year, when we were going through and doing work with rationals, I said, look guys, this is going to be something that comes back, and this is where I was thinking when we were doing all that work. So now taking a look at this part here, all right, so I've got 1 minus cosine theta minus sine squared theta. All of that is divided by the common denominator of 1 minus cosine theta. All right, so somehow this has got to go away. I've got to get rid of that sine squared theta. I don't have anything that can just knock it out, so I have to look over here and I see 1. So if I've got a square of some kind and I've got a 1, then what should be going through my mind is, hey, you know what? I have the Pythagorean identity. I'm going to change that 1 so I can see if I can get rid of this. So now we know that 1 is equal to sine squared theta plus cosine squared theta. Then I have the minus cosine theta. And then I've got the minus sine squared theta. Already I'm running out of room on this problem. And then all of that is divided by 1 minus cosine theta. All right. Well, this sine squared theta and this sine squared theta, they're going to go away because they add out to 0. So I'm left with cosine squared theta minus cosine theta, all of which is divided by 1 minus cosine theta. All right. Again, on your problem, on your quizzes, on your practice, you would continue down in the same column, one column, all the equal signs lining up. I do not have that luxury. I don't have enough room on my small screen. So I'm going to then come back up here and start my equal sign. But again, you would continue in a nice column with the equal signs all lined up. So somehow I got to get this and this to be the same. And I noticed that I have, sorry, fur from all the animals in my house. I noticed that I have cosine in each of these. So I'm going to take a cosine out. I hopefully also noticed that, look, you know, I got cosine here and I got cosine squared here. If those two were reversed and in a different spot, I could do some more work with it. But I'm going to take just the cosine out to start. All right, so cosine theta. And then I end up with cosine theta minus 1, all divided by 1 minus cosine theta. This would be great. I can almost get rid of them. I can almost say that these are common factors to the numerator and denominator, but they aren't because the signs are different. So then how do I get the signs to be the same? Well, if we notice down here that I could take a negative out as well, then I would just eliminated one step. But again, like I said in the last video, I don't care how you get there. I care that you get there and that your mathematics is correct and that your process is correct. Again, you can only manipulate one side at a time. You can't manipulate both sides. You can only work on one. All right, so now I'm like, oh, okay, well, I can take a negative out of this cosine theta minus 1. So let's do that. So I'm going to take a negative out. There's already a cosine theta that was out there. Now I have 1 minus cosine theta. And my denominator is 1 minus cosine theta. Well, these two factors, well, you simplify those to 1 because I've got the factor in the numerator, factor in the denominator, they become 1. When they become 1, then I'm left with just this that's in the front, which is the negative cosine theta. All right, so again, the hardest part, where do I start? How do I start? I want you to start picking up on some of these things. If I've got two fractions, then I need to work to get the two fractions together. Once I get them together, I'm just going to work on what's my numerator look like, clean that up, leave the denominator alone if there's nothing I can simplify. Then look for the common factors that I can simplify out and see what I have left over. All right, let's look at the second example for this particular one. Now, I've been using the left-hand side because, that was the side that had the most work that I could go through and do. There's a way I could do this using the left-hand side, but I don't know that that would be necessarily what you would all start with. So I'm going to start with the left-hand side because you notice how we have cosecant. Cosecant I can rewrite. I can rewrite cosecant as 1 over sine. Well, and if I do that, then I'm starting to see the same things that are over here. So let's go ahead and we will start actually with the right-hand side. Doesn't matter which side you start with so long as your mathematics and all is correct. So I've got cosine theta plus 1 in the numerator. Cosecant rather. Cosecant theta minus 1 in the denominator. Just like I said, the cosecant can be rewritten. And again, if I have things that are sine and cosine, then I want to change everything else to be those sine and cosines. If this was a cotangent and this was a tangent, I wouldn't change them all to sine and cosine. I'd leave them as tangent and cotangent. But notice here, I've got cosecants, I've got sines. I know I can rewrite cosecant. So cosecant is 1 divided by sine theta plus 1 divided by 1 divided by sine theta, minus 1. We got to add these two things together. Again, this is a common theme that I'm seeing. If I have a fraction, then I've got to bring the fractions within the fraction together. So I'm going to rewrite 1 as sine theta over sine theta. And this is probably going to have extra steps than what you might do, but as long as we can follow what you're doing, it's okay, it's acceptable. So 1 divided by sine theta plus sine theta divided by sine theta, all divided by 1 divided by sine theta minus sine theta divided by sine theta. Okay. Get these common denominators, bring them together. I now have common denominators. That's the whole idea. Got the common denominators, bring the fractions together. So I end up with, again, fractions within fractions, which is okay. It is what it is. 1 plus sine theta divided by sine theta over the larger fraction bar of 1 minus sine theta, all of which is divided by sine theta. Talk about squeezing it in. Again, you're going to get tired of hearing this, but again, I want to make sure this is all in a column. I make sure the equal signs are all lined up. I don't have the amount of room, so therefore I have to use the arrow. But if you're doing this on a quiz or a test or something else along those lines, please make sure that you have them all written in one column with the equal signs lining up. All right, during the year we've talked about how if the denominator, so if I have a fraction divided by another fraction, if my denominators are the same, then those denominators can actually go away because I have common denominators within a fraction divided by a fraction. And we've talked about that, but I want to show you again why that's possible. So when we divide by a fraction, it's the same as multiplying by the reciprocal. So this is a step that I will have in here that you could skip if you remember that when the denominators are the same, the denominators actually simplify out. And here we'll show why that happens. So I've got 1 plus sine theta divided by sine theta times the reciprocal of the denominator. So that means I get sine theta in the numerator divided by 1 minus sine theta in the denominator. Like we said, the sine thetas will simplify. I'm not going to cross them out because I'm just trying to have my work shown step by step. I'm not crossing them out, but I know that that and that are going to go away because they divide out to 1. So they do not contribute. So now I end up with my numerator being 1 plus sine theta and my denominator being 1 minus sine theta, which is exactly what we wanted it to equal in the first place. All right, so here were 2 more examples, a little different in their setup, but it's okay. Um, the process is the same. It's all about trying to figure out where do I start. But if you don't know your trig identities, you're not going to be able to do this. If you don't know how to simplify fractions, you're not going to be able to do this. If you're not able to deal with a fraction within a fraction, which is why we did rational expressions earlier this year and why you would do them also in Algebra 2, um, any areas of weakness that you have in this ability, it's going to show up, and it's going to show up hard in this. All right, so make sure we refresh our memory on what are those identities, what are the trig identities, how do I get them, how do I use them, how can I substitute, how can I manipulate fractions. It's all stuff we need to be able to do this. All right, again, thank you very much for your time. Again, this is Robert Main. How you doing? If this is helpful, go ahead and subscribe to the Charahoe Pre-Calculus YouTube page for more insights and more assistance. Thank you, and have a great rest of your day.